This is the video solution to problem number 3 in review number 2. So the first thing we're going to look at, again, is to see what it is asking for. And for A, we are looking to find the minimum break-even point. So the minimum, we're going to find the one with the smallest x value. As far as circling the point on the graph, I'll just do a sketch of that and I'll show you what that means. But we're going to be working with graphs in just a little bit and a little bit tomorrow. So it is asking for the break-even point. Let's just write this. So the break-even is when the revenue is equal to the cost. And what it is going to give us are 2 points. One with we have the quadratic function. Let me go ahead and just sketch the graph. So let's say we have this there, and then let's say we have our line. That would go like that. This would be the minimum. That's the smallest x and the smallest revenue at that particular point. So our revenue function, negative x squared plus 10x. Our cost function, 4x plus 4. Now we're actually solving for x, so we're going to actually figure out the x values. So in this particular case, to get everything to the left so that we have it set equal to 0, this is what we have. Now, I know some of us were working on this today in class, and this does not factor. So we would need to go ahead and use the quadratic formula. So let me just write that down again. B squared minus 4ac all over 2a. So in this particular quadratic, our a is negative 1, our b is 6, and our c is negative 4. So we have negative 6, that plus minus sign, 6 squared minus 4 times negative 1 times negative 4 all over the 2 times the negative 1. Now when I do that, I end up getting underneath that square root, we have the 36 minus, or actually plus minus 16. So we would have the square root of 20 all over that negative 2. Now, if you recall what that plus minus does, it gives us 2 solutions. So we would have that one, and we would have subtracting the square root of 20. This gives us 0.764, and this one gives us 5.236. So that is the x value of the break-even point. We would then need to figure out the y, but what we can identify right away is that this is going to be the minimum. So we would calculate the output, the y value of the break-even point, by plugging that in. Now we could actually plug it into either the revenue or the cost. The cost is just that 4x plus 4. That just looks a little bit more efficient to do. So we end up with 7.056. So our break-even point is the 0.764 for the x and the 7.056 for the y. So that is the break-even point. Letter B. It asks us to find the maximum revenue. So in this case, our revenue function, which is the negative x squared plus 10x. To find the maximum, we are always looking for a vertex. So in this case, we are using that negative b over 2a, and we would end up with negative 10 over 2 times negative 1, which gives us 5. So that's the x value of the vertex. So to figure out the output, which is the actual maximum, the output is the value we are looking for. We are going to place that 5 in our input to figure out the revenue. So what do we have here? We have negative 25 plus 50, which would give us 25. All right, so that was B. Now C asks for the profit equation and find the maximum profit. So in this case, we are doing C, and it asks for P of X, which, if you recall, is the revenue minus the cost. In this case, it was the negative x squared plus 10x. And then we had for the cost function the 4, and I always like to use these brackets. I know I told you guys that. 4x plus 4, so we get negative x squared plus 6x minus 4. So that is our profit function. So now we're figuring out the maximum profit. Again, we are going to use to find that vertex. Let's write that down again. So we have the negative b, negative 6 over 2 times the a, which is negative 1. So we would end up with 3. Now we need to figure out the output of the profit function at 3. So we're replacing every input or x with the 3. We end up with 5. So that is our profit. And that is problem 3.